Okay, question number 2. So this question is for 13 marks. So I have set the timer to 13 minutes. Let us see whether we will be able to solve it or not. Right. So a student is investigating a method to measure the mass of a wooden block by timing the period of oscillations of the spring. So you are describing in the SHM using a spring. Describe the conditions required for an object to perform SHM. What is the condition? Condition is acceleration is proportional to displacement. This is the first condition. Second condition, the direction of acceleration vector is opposite to direction of the displacement vector. Okay, these are only two conditions required. Then next one, 0.52 kg mass performs a simple harmonic motion with a period of 0.86 seconds. T, when attached to a spring, the wooden block attached to the same spring oscillates with a period of 0.74 seconds. Okay, so what is given? You have a mass m given. It oscillates with this mass with a time period t1 when attached to the spring. And if you attach a wooden block to this, then it oscillates with a different time period. Okay, calculate the mass of the wooden block. Comparison problem. What we do is, we know that time period t is given by 2 pi into root of m by k. Okay, so now same spring, k is constant, it's only time period is proportional to root m. So therefore I will write t2 by t1, because I want t2, I will take t2 on the numerator, should now be equal to m2 by m1, right? What is m2? M2 is what? M2 is unknown. Okay, m2 is unknown, so I'll write m2 just like this, divided by m1. m2 is what we need to find. M2 is fine, we need to find over here. m1 is 0.52, and what is t2 by t1? T2, what is T2? T2 is the second T, which is 0.74, and divided by 0.86. So is equal to root of m2 divided by 0.52. If I square both of the sides, then I get m2 by 0.52 is equal to 0.74 divided by 0.86, the whole square. Thus m2 should be 0.74 divided by 0.86, the whole square, multiplied by 0.52. Let us calculate this using our calculator. So I get the answer as 0.74 divided by 0.86 is equal to so much, and then I am going to square this. I get 0.74 multiplied by 0.52, I get this is 0.385. 0.385 unit is kg. So this should be your answer. So answer is 0.38 kg. 0.38 kg according to marking scheme. Okay, let us move on to the next one. In carrying out the experiment, the student displaces a block horizontally by 4.8 centimeters. So this is the spring. This is the spring, and you displace this object by 4.8 centimeters. So this was the equilibrium position. This is 4.8 centimeter. What is this? This is your x value. Determine total energy in the oscillation of the wooden block. What is the total energy? Total energy is given by just half k x square. But we know k is equal to half m omega square into x square. So in other words, let us calculate this. E should be equal to half into, what is this m here? When it says wooden block over here, what is the mass of this? Mass of this 0.38. I already told you in the previous videos also that the output of the previous problem will form the input for the next problem. But read the question anyway. Okay, most of the problems in IB are being designed like this. Multiplied by, so therefore output here was mass of this block, and you use this one here. Omega, what's the value of omega? Is the value of omega given to us? Which omega? There are two t's here, right? So we have to calculate this omega here. Omega is not given. Omega is nothing but 2 pi of, this should be 2 pi by t, and this t we need to correspond to the block over here, which should be 2 point divided by, what's the value of t? T is already given 0.74. So let us write down that 0.74 the whole square. Okay, omega square I have, multiplied by x square. X is 4.8 into 10 to the power of minus 2 the whole square. Okay, now let us calculate using our calculator. What are the values? So we will have, first let me calculate this 2 pi. 2 into 3.14 divided by 0.74. What is it? I get 8.48. Okay, so I will write down here as equal to half into 0.38 into 8.48 into 8.48, right? Okay, and then 4.8 square. 4.8 square. What is 4.8 square? 23.04. 23.04 into 10 to the power minus 4. So if I do the whole calculation, I get the answer as 0.38 into 8.48 into 23.04 divided by 2 will be 37.12. 37.12 into 10 to the power of minus 4, which should now be equal to, let me just recheck it once again. Okay, so this should now be equal to 0.03, so 1234 for 0.037 joules over here. The correct answer is 0.033 joules. 0.033 joules is the right answer according to marking scheme. Let me find out where did we go wrong or what was the calculation mistake. So let us find out this. 0.38 multiplied by 2 multiplied by 3.14. I made a mistake here. Just a minute. 2 into 3.14 divided by 0.74. I get this is 8.486. Now if I square this value, I get this much, multiplied by 4.8 multiplied by 4.8. I get this value, then multiplied by 0.38 is equal to so much divided by 2, 315. I think somewhere here there was a mistake. Okay, anyway, we got this right answer here. Okay, and then next, a second identical spring is placed in parallel and the experiment in B is repeated. You have one spring already connected to the block like this. You put one more spring in parallel to this like this over here. Okay, and then suggest how this change affects the fractional uncertainty in the mass of the block. Delta m by m, how does it affect? That's what is the question. So towards it, if I put one spring, what happens is, we know that T is equal to 2 pi into root of m by k. This is the formula we have. If I put two springs parallel like this, then what will happen to spring constant? Spring constant will increase. Okay, so if spring constant increases, this implies what happens? Time period will decrease. Why should it decrease? Because this denominator is increasing, time period should definitely decrease. Now what we do is, we'll take m as a subject. So if that is the case, I will now have t square is equal to 4 pi square m by k, or m should be equal to t square k divided by 4 pi square. Now delta m by m should now be 2 times delta t by t, 2 times delta t by t plus delta k by k. Now what's happening? When delta k, when k is increasing, delta c, when t is decreasing and k is increasing, definitely this value of delta m by m will also increase over here. Okay, and see what is happening here? K is increasing, t is decreasing. So therefore k is increasing means this will increase, delta k by k will decrease, this will definitely decrease. But since the t is decreasing, there is a 2 factor over here, so definitely this value will be larger. And as a result of this, now what can happen? Delta m by m will also increase. That's what you should write. You should write that the fractional uncertainty in determining the mass of the object will increase. Okay, let me check it out. Delta m by m increases. Okay, next, let us move on to the next one. With the block stationary, a longitudinal wave is made to travel through the block original spring from left to right. The diagram shows the variation with distance x. Okay, so you are now passing across a longitudinal wave. So this is the block like this. It's like this over here. Okay, and a point on the graph has been labeled that represents the point P on the spring. Let me consider this point P here. Point P is here. State the motion of the point on P on the spring. When you give an energy over here, then what can happen? So this point P is in equilibrium now. Okay, this is an equilibrium condition. So if that is the case, now what is happening to the point P? because when the wave passes through it, what can happen? See, this side there is an expansion over here to the right, which means there's an expansion here, and this side is a expansion in this direction, right? So therefore, you can say now what will happen when this is moving across. This will start moving towards the left of this. Okay. Now, how do I understand whether it's move to the left or right? If you ask this question, let me redo it once again. Now you see, when there is a wave which goes in this direction, now where should the wave start? It should start from here, right? Let me draw one more wave. Let me draw one more wave here, parallel to this. So that the peak is somewhere over here. Let me draw it like this over here, right? When I draw it like this over here, this peak will be here, and then once again this comes over here. It goes like this over here. Now from this point, draw a vertical, draw a perpendicular downwards, so that it intersects the curve here. See, this is the curve. The curve looks like this over here, and then this is the point P here. The points perpendicular will be pointing downward over here. So which means when you say it is downward, which means the displacement is towards the left over here. Okay, one more way of inferring this. So therefore you can say it is towards the left over here, because the point P has to vibrate in some direction. How does it vibrate? It vibrates according to the profile given over here. The profile here illustrates this is the point over here. So therefore this vibrating towards the left. Why left? We can say it is downwards, but look at this here. The downwards means it is displacement to the left over here. Okay. Next, let us move on to the next one. Explain whether P is at the center of a compression or at the center of a rarefaction. This question is clearly addressed over here. So there is an expansion here, there is an expansion here, there is P here. P is at the mid between two different expansions, which means an expansion is nothing but rarefactions. So it is the midpoint between two rarefactions. Rarefaction is what you can say. Okay. So I think with this we have come to an end to this particular problem. This problem is quite interesting because it has SHM and waves together. So these kinds of problems are seen to be more prominent. So do look into this, such kinds of problems, very important, and moreover such kinds of problems are very important. Look at the graphical analysis, how to solve it. So before you go out from this video, do like, share and subscribe to my channel for more updates. We will be bringing in more number of problems for you. Thank you for being until the end.